Okay, yesterday we were discussing about LCM and HCF. Okay, I've told you how to find out the HCF and LCM simultaneously. In HCF, what we are doing, we are trying to get the number which can divide all the given numbers at a time. Okay, and after that is done, we'll go for the regular process of finding the factors for at least two numbers. There we get the LCM. In HCF, we take only the factors or the divisors into consideration. If there are no factors at all, if there are no common factors for the given numbers, then what do? We just take the HCF as 1. Okay. Then with respect to LCM, like we have to take divisors. That too, the divisors which have divided all the given numbers, divisors which have divided at least two given numbers, and finally we take the quotients also into consideration and write the LCM. And I have told you, like when we are finding the HCF and LCM of two numbers, there is one formula that is applicable, that is product of two numbers is equal to product of the LCM and HCF of those numbers. Okay, then if two numbers, though they are composite numbers, if they don't have any common factor other than 1, if the HCF of two numbers is 1, then we call those numbers as co-prime numbers. Co-prime in the sense they are prime to each other. They are prime to each other. Fine. Then there are many applications of this HCF and LCM. And already have told you, like when we are finding the HCF, always we are looking for smaller number. When we are looking for the LCM, we are looking for a bigger number. Okay. So when the question is given in the question paper, like you have to decide first which problem is it. Usually when there are more than, like not more than, I can't say like that. Like when 2, 3, 4 continuous values are given, 2, 3, 4 continuous values by comma, 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 usually that is a LCM or HCF problem, because you have to find either multiple of them or you have to find the factor of them. Okay. And when you enter the question, then you will understand whether you are looking for a bigger number or you are looking for a smaller number. If you are looking for a bigger number at the end, then you are finding LCM. If you are looking for a smaller number, then you are finding what? HCF. As simple as that. Okay. I think I had given these problems for homework. Have you done? Yeah. What is the answer for this? Huh? Don't take me for granted that I will solve all the problems. No. I need 1,000 hours if I solve all the problems of all the chapters. Okay. What is the answer? No one? HCF is 1. HCF is equal to 1. LCM 4536. Very good. What about this? HCF 15 and LCM 450. Very good. Okay. After this, we'll learn a small concept based on LCM and HCF only. That is the LCM and HCF of fractions. LCM and HCF of fractions. Okay. There is no difficulty in this. When you know how to find out LCM and HCF, it is simple. It is simple. You have to apply only one formula before you go to find out that one. And other process is regular, like what you have done earlier. Okay. LCM of fractions is equal to, you are finding LCM, so you have to find out the LCM of numerators. LCM of numerators. Then when you have found out LCM of numerators, in the denominator you are finding the HCF of denominators. That's it. Done. But in every transaction, we are finding two different things. LCM of fractions and HCF of denominators. Similarly, if I want HCF of fractions. Again, you have to find the HCF of numerator divided by LCM of denominator. Opposite things. Here you want LCM, so you are taking the LCM of numerator. Here you are taking HCF, you are taking the HCF of numerator. In the denominator, the opposite thing will come. Here if you have taken LCM, here HCF. If you have taken HCF, here LCM. Tough to remember? Easy to remember, right? Okay, simple. So find out the LCM and HCF of these fractions simultaneously. First, let us find out the LCM of these numbers. LCM of these numbers. LCM of numerators you take. LCM of 2, 8 and 5. Quick. LCM of numerator. You don't need pen and paper for this. Or one more method I'll tell. See, rather than going for all three numbers, first tell me the LCM of 2 and 8 is how much? LCM of 2 and 8. 8. Keep that. Then LCM of 8 and 5. We don't have any common factor, so you have to multiply them. 8 5s are 40. This way also we can go. You take the LCM of two numbers, then keep that number and get the LCM with other number. That also can be done. So here LCM is equal to 40. Then HCF 9, 27 and 18. You are finding a factor which can divide all of them, and that to the highest. Yeah. LCM is, HCF is 9. So LCM of these fractions is 40 by 9. Similarly, HCF. What is the HCF of 2, 8 and 5? HCF of 2, 8 and 5. Do you have any number which can divide all the given numbers? No. Simple. 1 divided by the LCM of, LCM of denominator. LCM of denominator. 9, 27 and 18. Quick. 9, 27 and 18. Don't do collaborative solution. Okay. Every one of you do. Don't depend upon your neighbor. Okay. And it is not like you find LCM, I'll find HCF. No, don't do that collaborative business. Okay. So 9, 27 and 18. You can divide by 3 twice. Then you will get 3 into 3 into 2 into 3. 54. Yes or no? Similarly, LCM of these fractions, 5, 3 and 4. What is the LCM? You don't have any common factor there. You don't have to divide. Just multiply 5 into 3 into 4. 60. 8, 16 and 6. HCF. 8, 16 and 6. 2. So 60 by 2 is 30. Yeah? Yes? So HCF. HCF of 5, 3 and 4. 1. LCM of 8, 16 and 6. Quick. LCM of 8, 16 and 6. Quick. 20 seconds. LCM of 8, 16 and 6. Work. 8, 16 and 6. How much? First you will go with 2. 2 4s are, 2 8s are, then 2 3s are. Then again you will go with 2. 2 2s are, 2 4, correct? 2, yeah, 2 2s are, 2 4s are. Again you will go 2. 2 into 2 into 2 into 2 into 3. 48. So 1 by 48. Done? Is it tough? LCM and HCF of fractions, is it tough? Whatever that you want, you have to apply it to numerator. That's it. The opposite thing you will apply in the denominator. Okay. Next, LCM and HCF of decimals. I've told you fractions and decimals are same thing only. When you don't want any denominator, we write it in terms of decimals. That's it. We divide them perfectly and keep them. Correct? Fractions, we keep it open-ended. We keep denominator also, we keep numerator also. Okay? All the numbers can be called as fractions and decimals. All the numbers, all the natural numbers, all the integers, we can call them as fractions and decimals. But all the fractions and decimals are not the natural numbers or the whole numbers or the integers. Okay, because 2 can be expressed as 2 by 1. That is a fraction. 2 can be expressed as 2.0. That's a fraction. That's a decimal. So we have to understand this fact. Okay. Now, in decimals, always, for example, in multiplication, while you are doing the multiplication of decimals, what did you do? Try to remember. Decimal into decimal. What you used to do? How you used to treat that point? I'm not asking division. I'm asking multiplication. When you are multiplying, let's say 2.46 into 1.2. First, don't consider the point at all. Do the sum. Then give the point back. Similarly, here we have to get rid of the point. First of all, we have to get rid of the point. Point of all the numbers. So we have to shift the point towards right so that there is no point in any number. Getting my point? And whatever you do for one number, you have to do it for other numbers also. Whatever you do for one number, you have to do it for other number also. In this, after decimal point, how many places are there? Here, here. So basically we have to jump twice, or you have to shift the decimal point towards right, yeah, for all the numbers, not just one number, all the numbers. So this will become 135. This will become 15 or 150. Very good. This one. Now do whatever you want. LCM or HCF. Whatever you want, you find out. So find out LCM and HCF for this. First HCF, you will start with 3. 345s are, 350s are, and 315s are. Again, you can't try with 3 because you have 5 which can divide all the numbers. 3 will divide only 2 numbers. So that is why take 5 and try to divide all the numbers. 5 9s are, 5 10s are, and 5 3s are. Now stop the process for HCF. 3 into 5, 15. So HCF is 15. But is our answer right? We had jumped the decimal points, no? Give that back. You had jumped the decimal point 2 places to the right. Now give the decimal point back. Again 2 places to the left. So here your answer will become 0.15. Understood? Same thing with LCM. Again proceed here. You will apply with 3. 3 3s are, 3 1s are, write 10 like that. Now multiply all the numbers. Multiply all the numbers. 3 into 5 into 3 into 3 into 10. 15. 3s are 45. 3s are 135 into 10. 1350. So LCM is equal to 1350. But is it our expected answer? No. Give back the decimal point. So this answer will become 13.5. 13.5. 13.5 or 13.50 or 13.50. You know, huh? It is not 13.50. You know, right? So when you call Narendra Modi, please tell him. Okay, it is not 13.50. It is 13.50 because He makes a lot of mistakes while reading decimals. I don't want our Prime Minister to be a mathematician. Our Prime Minister is followed by crores, billions of people. I don't want those people to be wrong just because our PM is wrong. Okay, fine? Yeah? So reading the decimal after point, you should be reading every digit individually, not as a whole. Okay? If you want proof, if you want the reason, I can give. But let us not worry about that and waste time. Okay? If you want outside the class, I'll give. Now, this one, jump 2 points. Because maximum points that we have is 2. So here it will become 8. Here it will become 32. Here it will become 40. Sure? Now go for HCF. 2 4s are, 2 16s are, and 2 20s are. Similarly, 2 2s are, 2 8s are, 2 10s are. Again 2. 2 1s are, 2 4s are, 2 5s are. HCF journey is done. HCF is equal to 8. But is it the right answer? No. Give back 2 points. 0.08. Not just single. 0.08. Correct? LCM, will you divide 4 and 5 with any other number? Even the journey for LCM is done here. 2 into 2 into 2, 8. 8 into 4, 32. 32 into 5, 160. So LCM is equal to 160. This is nothing but 1.6. 1.6. Tough? Is it tough? It's okay, no? Yeah? Manageable? Yeah. Now, why we are learning LCM and HCF? That too the LCM of fractions and decimals. Because the questions are coming in the examination. And that too application oriented questions. Okay, I told you directly they will not ask these questions like find the LCM and HCF of so many numbers or so many fractions or so many decimals. They will give a question in sentence format and then they will ask you to find something. And I already told you, like as soon as you see the question, you have to decide whether it is a LCM problem or HCF problem. If you are expecting a bigger number in the answer, then you have to find out the LCM. If you are expecting a smaller number in the answer, then you have to find out HCF. Fine? Okay? Yeah. Usually, the problems of HCF, they'll be asking smaller number. They'll be asking smaller number. For example, I'll give you, there are 3 rods, or let's say there are 3 ropes. There are 3 ropes of different lengths. One is, let's say, 15 meter, another is 20 meter, another is 25 meter. And you want to cut those ropes into equal lengths. And you are cutting the ropes into equal lengths, keeping in the mind that you are getting the maximum length for each piece of rope. You are cutting each rope and you are finally getting the maximum length of the rope that is possible. One rope is 15 meters, second rope is 20 meters, third rope is 25 meters. You are cutting them into the equal lengths. That too, those equal lengths must be highest possible lengths for those ropes. So what should be the length of rope? You are cutting it. First of all, decide you are cutting a bigger, or if you are cutting a longer rope into smaller. That means you want HCF or LCM. You want smaller number or bigger number? Smaller number. So you are finding HCF. Whenever you are cutting, whenever you are making a bigger thing into smaller in the answer, that is HCF question. Whenever you are expecting a bigger number at the end, then that is what? LCM. First of all, we'll solve the HCF related questions. Same. I used rope, here rods. Same thing. 4 metal rods of lengths 78 centimeter, 104 centimeter, 117 centimeter, and 169 centimeter are to be cut into parts of equal length. Parts of equal length. So what we are doing? Cutting. Equal length. Without thinking too much, start finding the HCF of these numbers. Start. Then after you get the solution, let's see what exactly we have to do. Which number can divide all the given numbers? You have started with 2? No? Sure. 3. If you start with 2, 117 cannot be divided. 78, 104, 117, 169. When there is even single odd number, you cannot divide that by even number. So go for the prime numbers. 3. You can divide this and this, not this. 5. You cannot divide anything. 7. No. 11. No. Even one number is not divided, leave that number. Then 13. For that you have to learn. 13 6 are, 13 8 are, 13 9 are, 13 13 are. Done. Any further? We are not finding LCM. This is done. So what is HCF now? 13 is the HCF. What does that mean? We can make the smaller pieces of length 13 centimeter from each rod. But what is the question? Let's see. What is the maximum number of pieces that can be cut? What is the maximum number of pieces that can be cut? But we want what? We want the equal length. That is what we are trying. And also we want as long as possible. Equal length, basically we are finding common factor. As long as possible, that is highest common factor. Yes. So now they are asking the number of pieces. If you write the answer as 13, that is HCF, that is the length of each piece. But they are asking number of pieces. In this rod, how many pieces we have got? In this rod, 9, 13. So these are the number of pieces. We have to make the sum of them. We have to make the sum of them. So how many totally? 6 plus 8 plus 9 plus 13. 36. Usually in hurry, if the option is 13, people tick 13 and move forward. Yeah. Last sentence is very important for a question. You have to read it twice, not thrice. Twice. If you read it thrice, one more meaning will come to your mind. Even in the examination, maybe GS, you have to read the sentence or the statement twice. If you read thrice, you start reading in between the lines. You will understand different meanings of that one. You will go too deeper. Sometimes you will go to the imagination world also. 2 times. Proper 2 times. That's it. You don't have that much time to waste also. If you read every sentence 3 times, you require 3 hours. Only 2 hours are there. So you can read every sentence only twice in the examination. Okay? Done this one? Understood? Next. What is the greatest length? See, this is always confusing, okay? They are asking greatest length. Usually our mind will go towards LCM. Highest common factor. Still we are finding the smaller one. In the factors, that is the highest. Okay? So, the greatest length x such that 3.5 meter, 8 integer 3 by 4 meter are integral multiples of x. Hold on. Multiples of x. That means what? If we multiply anything with x, we get those values. Integral multiples means what? This n is nothing but an integer. Here it is to confuse you. If this was straightly asked that are multiples of x, then everyone would have solved, right? Here this integral word will kick out at least 10% of the people. Because they will wonder, what is integral? I have not studied integration and all. So they will get confused. So it is not. It is a number which is integer. Integer means both positive and negative numbers. Okay, don't worry about this word. So what we are doing? We are finding a number. That means we are finding a factor of these numbers. One is 3.5. Another is 8 integer 3 by 4. These are fractions. Convert them into proper fractions. That is, then we can't call them proper fraction, they are improper fractions. Proper fractions, always the numerator will be smaller than the denominator. These are improper fractions. Now find out the HCF. We want HCF. HCF of these two numbers. Quick. 7. Yes? Smart. You people are not working. 7 ones are 7 5s are. Good. Then LCM of 2 and 4. LCM I am asking. 4. So expand this or make it into mixed fraction. 4 ones are 4. Remainder is 3. 1 integer 3 by 4. Is it tough? Is it tough? No, right? Tell no. Tell loudly. I'll become happy. A student never wants the teacher to be happy, you know. They always want to keep him cornered. Show grim face. What you are doing, man? Done? And these questions, I am seeing it only since last 3 years, okay? The LCM, HCF of integer, the decimals and fractions, it is a new phenomena. They have started coming up only now. Until 2018, we have not seen these questions, okay? That is why it is important, because 50% of people won't do it, because first of all, they have not learned LCM and HCF after school, and that too of fraction and decimal, definitely they will get panicked, okay? If you have two straight sticks of length 7.5 meter and 7.5 feet and 3.25 feet, what is the minimum length you can measure? Sticks are there. They are not giving you any kind of scale. They are not giving you any kind of scale. Only sticks are there. They have told you that it is one is 7.5, another is 3.25. One is 7.5, another is 3.25. You can only break the stick. You can only break the stick. And they are asking you what the maximum measurement that you can do. What is the minimum length that you can measure with these rods, with these sticks? One is this much, 3.25. One is this much, 7.5. This is 3.25 and this is 7.5. The minimum length that we can measure is 3.25 now. Yes? Yes or no? Yeah. Now, you cut, you hold them together, you cut it. So how much will be remaining here? If I have cut 3.25 from this bigger rod, bigger stick, how much is remaining here? Tell louder, no. 4 point, correct? 4.25. Getting the point? Yeah. Now, I have one rod, one stick of 3.25, one more stick of 4.25. Bring this 3.25 and keep along with this one. Again cut it. What is the minimum length that you get? Yes. Now there is 3.25 and 1 feet. keep 1 feet, cut it, keep 1 feet, cut it, keep 1 feet, cut it. What will be remaining? 0.25. That is the minimum that is possible. This is practical terms. But God has given us one tool, HCF. Yeah, find out the HCF. That is of 7.5 and 3.25. One advice, no matter you are finding the LCM or HCF of decimals, convert that into fraction. The things will get easier. Okay, I'll show you. This 7.5 can be written as 7.5. Yes. And this 3.25 can be written as 3 integer 1 by 4. Yes. Convert them into improper fraction. 15 by 2. Here 13 by. Now find out the HCF. HCF of numerator 1, right? Both are prime numbers. 1. Divide by LCM of denominators. 4 or 2. So this is the minimum length possible. Yes? But 325 it is not familiar for you. I know. You will go with 5. Divide, again go with 5. Yeah, that is up to you. No issues at all. But 325 usually you have not seen. If I have not seen much, definitely you have not seen. Yeah. But smaller numbers, very safe to calculate. Okay. Done? No issues? Yeah. And this is practical approach. For the person who hasn't learnt the LCM and HCF of fractions or decimal, that person will do this. But while breaking, he will make mistake. Not sure that always the correct. Maximum length is there only, no? 7.5. See, we are allowed only to break the stick here. Okay. You can ask me, sir, in 0.25 also, you can break into tukada, no? But we don't know the exact measurement. You are asking if maximum length is, then there is no end only. You take 7.5 meter stick, 7.5 feet stick, you can measure anything, no? Anything in the world. Yes? Try to understand. Yes? But here, if you don't apply this logic of breaking the sticks, the minimum length possible is this. Yes or no? If you apply your brains of cutting the sticks with other measurements and all, then the minimum length that you can achieve is 0.25. Don't train too much. Simple, find the HCF and finish it off. Okay, fine. Yeah. This is also related to, you will tell me what this problem is about. What is the least 4-digit number? You forget about this, okay? Least 4-digit number, I'll tell you later. When divided by 3, 4, 5, 6, when divided by 3, 4, 5, 6, that means you are dividing a smaller number or bigger number. I have already shown. Yeah. You are dividing a number by 3, 4, 5, 6. So you are expecting a bigger number or smaller number? Bigger, sure? Yes? Yes or no? Then what we are finding? LCM or HCF? LCM. Bigger number, LCM. Without thinking anything, find the LCM of these numbers. 3, 4, 5, 6. I'll give one more clue here. Rather than going for all the numbers, find out the LCM for 3 and 4. What is the LCM of 3 and 4? 12. LCM of 5 and 6. Find the LCM of these two. 2 6s are, 2 15s are, 2 3s are, Not 2 3s are 3 2s are 3 5s are 2 into 3 into 2 into 5. LCM is, this is practical, okay? In the long run, when you are finding the LCM of many numbers, you can use this because 4 numbers are reduced to 2. Okay? It can be applied to any numbers, any number of numbers. But you have to write their LCM. Here you have to write their LCM. Or let's say only 3 numbers are there. Find out the LCM of these 2 and find out the LCM with the previous LCM. You can apply it to anything. Okay? Or you can find LCM of 2 numbers. Again, take the third number. Again, find LCM. You can go like that also. That is all applicable. Okay? For HCF, it is not. Okay? Fine? Now, 60 is what? 60 is the number which can be divided by 3, 4, 5, 6. Yes or no? You can divide 60 by all these numbers comfortably. Comfortably. Yes? But they are telling it should leave a remainder of 2. Whenever you divide a bigger number by 3, 4, 5, 6, the remainder must be 2. If you divide this number 60 by 3, 4, 5, 6, what will be the remainder? 0. You add 2 to 60. 62 is the minimum, the least number which can be divided by 3, 4, 5, 6 and which leaves remainder 2. But what we are trying to find out? We are trying to find out the 4-digit number. First of all, we have to divide least 4-digit number by what? 3, 4, 5, 6. What I will do, instead of dividing it by 3, 4, 5 and 6, I will divide by, very good, I will divide by 60. Not 62. 60. Later we will add remainder. Adding deficit or subtracting the excess will happen at the last stage after division. Okay? So 60. Quick, give me 61s are 60, 400, 60. What? What is the remainder? 40 is the remainder, correct? Now, what is this? Deficit or excess? Remainder is always excess. But we want to retain 4-digit number. Should I subtract the excess or add the deficit? Add the deficit. What is the deficit? Excess is 40. Deficit is 20. Correct? Add 20. What it will become? 1020. Remainder also you want, no? So it will become 1022. Or reverse engineering method, Jugaad method. Remainder, anyways, remainder is in every number. Take out that 2. Take out that 2. You will be remained with what? 1010, 1020, 1120, 1220. See if those numbers are divisible by 3, 4, 5, 6. First of all, this number is not divisible by what? 3. You can't divide this by 3, no? You can divide this by 3. 1020. Yes? 1120 you cannot divide by 3. 1220 you cannot divide by 3. Simple. Answer is here. Without doing anything. Without doing all this drama. But teaching this is my karma. I have to teach this. I can solve more than 50% through options only. But you are not here for that. You are here to learn the concept. Yes? So, here, leave out the remainder. Check all other numbers whether they are divisible by 3, 4, 5, 6 or not. Got it? But let us not do that at this point of time. When you are expert in these questions, you can do that. Okay? First, let us learn the concept. Classical problem of You will tell me whether HCF or LCM. Classical problem of HCF or LCM. The traffic lights at 3 different signal points change after every 45 seconds, 75 seconds and 90 seconds respectively. Think of 3 bulbs, okay? Don't imagine traffic light. You will ask me, sir, whether it is red, yellow or green. Don't ask me that one. So here basically 3 lights are there. 3 lights. They are becoming on after 45, 75 and 90 seconds respectively. First bulb will become on after every 45 seconds. Second bulb will become on after every 75 seconds. Third bulb will become on after every 90 seconds. Now, let's say we have switched them on at a time. How long we have to wait for the next time when all these 3 lights glow together? We are waiting for shorter time or bigger time? Shorter than the given numbers or bigger than the given numbers? Bigger than the given numbers? Yes, because it is not a very common phenomena. It is a rare phenomena. We have to wait. For example, 3 people are running around a circular ground. They started together to run. They have different speeds. That means the time required for them to cover a full circle are different. If they have started together and they are running around the circular ground, when they will meet again, all 3 of them, when they will meet again, will you wait for shorter time or longer time? Yes, understood? So it is the problem of HCF or LCM. Both are heard same, okay? L and H are heard same, C is heard same, F and M is heard same, okay? It is LCM. So find out the LCM of 45, 75 and 90 quickly. 45, 75 and 90. $45, $75 and 90. Quick. First you will try with 3. 315s are, 325s are, 330s are. Then you will find with 5. Yeah? 3s are, 5s are, 6 are. Then again 3. 3 1s are, 3 2s are. So finally it is what? 3 into 5 into 3 into 2 into 3. 450. So LCM is what? What does this mean? What does this mean? LCM is equal to 450. What does this mean? We have to wait for 450 seconds to see that phenomena again. Yes? Yes? Yeah. 450 seconds. But for once they were on together. At what time? 7 hours, 20 minutes and 15 seconds. In the morning they were on. Only after 450 seconds we are seeing the phenomena. So for how many minutes we have to wait? How to convert? 450 seconds into minutes. I will not tell this. Divide by 7 minutes and that means 7.5 minutes. 450 seconds is 7.5 minutes. So add 7.5 minutes to this. 7 hours, 27 minutes and 45 seconds. And you have to be careful about AM, PM also. In the same question, there can be same options with AM and PM. Please be sure about that. Yeah? So this is briefly about LCM and HCF. You will get many applications like this. Okay? Next, You can drop your pen and paper for few minutes and listen to this. Last digit logic. Actually, until 2017-18, I used to teach this last digit logic. But looking at the paper from 17, 18, 19, 20 and all, these questions were not asked. So I thought of dropping it. So for the last year, I had dropped it too. Simply why to, fill so many things into the student's mind. But last year, one question has come from the last digit logic. That is why it has compelled me to teach it again. Okay, simple. Take any power of a number, let's say 2 to the, I'll start with, here I'll write the base, here I'll write the index, so base 2 and the index is, let's say 1. So number is 2 to the power of 1. Like that. Index is 2, 3, 4. 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. You don't give me the answer of these powers, but tell me the last digit of those numbers. 2 to the power of 1 is what? 2. 2 to the power of 2. 2 to the power of 3. 2 to the power of 4, last digit, 6. Similarly, 2 to the power of 5, last digit, 32, 2. 2 to the power of 6, last digit. 2 to the power of 7, last digit. 2 to the power of 8, last digit. 2 to the power of 9, last digit. See here, after every 4 powers, there is a same pattern. There is a repetition of pattern. Yes or no? Yes? Now go for 3. 3 to the power of 1. 3 to the power of 2. 3 to the power of 3. 27. So last digit is 7. 3 to the power of 4. 81. Last digit is 1. Then 243. Last digit is 3. Then 729. Yeah, you will just go like this. You will get the same repetition. So what is it? After every 4 powers, the last digit of the number will repeat. Take any number for that matter. Okay, take any number for that matter. There are variations also. For the numbers like 4 and 9, the repetition will happen after 2 powers only. For example, 4. 4 to the power of 1, 4. 4 to the power of 2, 16. 4 to the power of 3, 64. 4 to the power of 5, 256. 4 to the power of 5, 1024. Then 6, 4, 6. For the numbers like 5, 5 to the power of 1, 5 to the power of 2, 5 to the power of anything will end in 5. 6 to the power of anything. Similarly, 0 to the power of anything. 1 to the power of anything. 1. So, few numbers are repeating every time. Few numbers are repeating after 2 powers. few numbers are repeating after 4 powers. But generally we can take, like the repetition will happen after every 4 powers. Because the maximum repetition is 4, right? So, be it any number in the world and any power in the world. Any power in the world. You take anything like 3, 8, 6, 5, 7 to the power of 2, 3, 4, 6. You can find out the last digit of this. You can find out the last digit of this. Okay? How? First step. Write the last digit of base. Write the last digit of base. What is the base here? Divide the power by 4, then write the remainder. Take this number and divide it by 4 and tell me the remainder. I know you will start with your machine gun. Every time I ask you, open your machine gun, apply your brains. While we are finding the divisibility by 4, we are focusing on only last 2 digits, right? Take 46 and divide. Take 46 and divide. What is the remainder? Tell. 4 ones are 4. Again 4 ones are 4. 6 minus 4. Remainder is 2. So, write the remainder. So, what is the remainder here? 2. So, this whole expression can be replaced by 7 square. This whole expression can be written as 7 square. Yeah? What is the value of 7 square? 49. What is the end digit? 9. So the end digit of this expression is 9. Simple. You can ask me, what if the remainder is 0? If remainder is 0, then that will spoil the sport, no? Wherever 0 comes, it becomes 1, no? That is wrong. It will not be like that. If remainder is 0, write 4. Write 4. If remainder is 0, write 4. And it can be applicable for any question, any base, any index. Okay? Take one question. Take one question. Five three eight three to the power of 287. Find the last digit of that number. In the base, what you will write? 3. In the index, in the power, what you will write? 287 divided by 4. Simply 87 divided by 4. What is the remainder? 87 divided by 4. Remainder is what? 3 to the power of 3. What is the answer? 3 to the power of 3? 7. So, end digit is 7. So, the end digit of this number is 7. Understood? One more problem. Yeah? Give me the answer, not the intermediate step. Give me the answer. That is not the answer. That is intermediate step. I'm asking the last digit. That you have to work out. Yeah. So the last digit is 7. And if you divide this 48 by 4, remainder is 0. When remainder is 0, give 4. 7 to the power of 4. Bit difficult. 7 square is 49. 7 to the power of 3 is 343. Again, why you are working the whole number? 343, take that last 3 into 7. 3 into 7, 21, no? So 1. Understood this? No issues? Remember these steps. Okay? If you have not taken, you can take them down. Have taken down? Yes? We can solve a question pertaining to this. This question. If 3 to the power of 2019, it is divided by 10. Divide by 10 means what? When you divide anything by 10, what will be the remainder? Take any number and divide it by 10. What will be the remainder? Last digit itself, right? Take any number. Divide by 10. What will be the remainder? 8, no? So indirectly they are asking last digit. Last digit is nothing but the remainder of a number when divided by 10. Yes or no? So they are asking the last digit. Work out. 3 is the base. And 2 is on 19. Take 19 and divide by 4. What will come in the remainder? 3 to the power of 3, 27. Answer is 7. Done? No issues? Tell me no issues. Yeah? Then, have you heard of this word, surd? Not curd, surd. Have you heard of this word? No. Seriously? No. Now, yes. I'll not tell anything. No problem if you are not heard. It is not a great miss in life. Without knowing this word, you have studied this thing already. Okay? Whenever you write something in the form of a to the power of m, it is nothing but surd. But basically it is the mth root of a. We can manage with this thing. So one base and one power. So that is called as surd. Can we call 2 as a surd? Can we call 2 as a surd? Yes, 2 to the power of 1. Yeah. So a to the power of m. Why we are using this? Because we do certain basic operations with this surd, a to the power of m. You might have done with these things. Yes? Somewhere in school. Yes? Remember? Now tell me the expansion of this. a to the power of m. What is it? A to the power of m plus n, or let's see. Then here a to the power of m minus. I'll like make everyone happy. She has told a to the power of m minus 1. Anything from here? Okay. Any other? Okay. What about this? Any other? Fine, no? What about this? Actually, here I am allowing my favorite subject to be killed in the daylight. People are killing it without thinking anything. Murdering. That too in daylight. That too in front of the disciple of maths. Where you have learned this? Which teacher? Which book? It's all just nonsensical construction of our mind. Only the like legitimate thing, only the correct thing, just because we know this, we are applying it to like got it? This is absolutely nonsense. There is no shortcut for a to the power of m plus a to the power of n. And even for a to the power of m minus a to the power of n, there is no shortcut. But for here, we have. Take the example and work out, no? For example, here 2 to the power of 3 plus 2 to the power of 4. What do you get? According to one person, I have to get 2 to the power of 7. According to one more person, I have to get 2 to the power of 12. But what is the real value? 2 to the power of 3 is 8 plus 16. Totally 20. I cannot express this 24 in terms of 2 or powers of 2. Okay. So there is no shortcut for this. Even for this, there is no shortcut. You take the example 2 to the power of 5 minus 2 to the power of 3. 2 to the power of 5 is 32. 2 to the power of 3 is 8. Answer is 24. You cannot express in terms of powers of 2. Okay. Just try to remember this. Okay. This is very much practical. 2 to the power of 3 into 2 to the power of 4 is equal to 2 to the power of 7. Because 8 into 16, 128. 128 is 2 to the power of 7. Similarly, 2 to the power of 5 divided by 2 to the power of 3 is nothing but 2 to the power of 2. Because 2 to the power of 5 is 32 minus, divided by 8. 32 by 8 is 2 to the power of 2, that is 4. Then, kindly remember this and delete this from your mind. Never in life again it should come to your mind. Okay? Along with these things, we'll learn other few important things. What about a to the power of 1 by m? Take the example like this, 3 to the power of 1 by 2. What does this mean? When we are writing it in the fraction, the power is in fraction. This is nothing but mth root of a. This is nothing but square root of 3. Understood? Then a to the power of minus m. How do you write it? Yeah, very good. 1 by a to the power of m. Example, 2 to the power of minus 3. That means 1 divided by 2 to the power of 3. Yes. One more thing. A to the power of m whole to the power of n. A to the power of m whole to the power of n equal to a to the power of mn or m into n. So these many things you have to remember. They don't come as if, like how we are dealing with this formula. They will come in application form. Okay. So we have to apply these things. But while we are doing the operations, we have to be extra careful. Okay. Fine. So think of this question. Think of this question. Have you noted all these down? Yeah. What is the largest number among the given numbers? First, you have to express them properly. First, think of this power minus 6. Minus 6. How should I write this? 1 divided by 1 by 2 to the power of 6. 1 divided by 1 by 2. Apply this 6 to both. Can I? That is the right method of doing it. Correct? Now, denominator of denominator will go to numerator. So this is 2 to the power of 6. 1 to the power of 6 don't have value. Discard them. Okay, 2 to the power of 6. So this can be written like this. Similarly, write these things straight away. 2 to the power of 6 here. 4 to the power of 3. Here, 3 to the power of 4. 6 to the power of 2. You should not do this step to all these things. Similar, no, only numbers are changing. Now tell me which is the highest here? Which is the highest here? Largest number. 2 to the power of 6 is 60. Yes. 4 to the power of 3 is 60. 3 into 3 into 3. Very good. One more 3. 81. 6 to the power of 2. So which is the highest? Simplest problem. But in the examination, people will think that I don't know this. Because they don't know the basics. They will leave this problem. Simplest problem among all the problems last year. But still, they will leave this problem. Okay? You should not reach to that level. That is why I am picking every minute in the numeracy and teaching you. Earlier to this, I have not done. Because so many questions were not asked from numeracy. But since 2020, like many questions are coming from numeracy. Then reversing the digits. Again, it is a fun factor. Fun factor. I'll tell you how. If your writing thing is done, if you are not writing anything important than our Indian Constitution, please drop. Yeah. Reversing the digits. Usually, these questions come when the number is of 2 digit or 3 digits. Okay? Take any 2 digit number. You give me a number. 84. Reverse it. Add it. Add them. How much it will be? 1. Okay. Take the difference of them. 84 and 48. Take the difference of them. 30. Okay, now one more number. Very good. 24. Reverse it. Sum. Difference. Don't tell minus and all. Just difference. 18. Yes. One more number. Anyone? Reverse. Add. Add. Difference. 91 and 19. Difference. तुक्का नहीं लगा. Okay. 91 minus 19. Seriously? Now check all the sums. We have a common factor here. 11. You can say 22 also. But if you take the odd number, sometimes, the difference is odd. You get. So all these numbers, like when we take the number and reverse it and add them, they are divisible by 11. So sum of those numbers are the multiples of 11. I'll give you the sentence. You can write later. Look at the differences. 18, 36, 72. Multiples of 9. You can ask me, sir, multiples of 18? No. Only these examples are giving such. But if you take all the cases, they will be in the form of 9. So write down. A two-digit number and its reverse. And its reverse give the sum of multiples of 11. In the line below, right? A two-digit number and its reverse give the difference of multiples of 9. Yes? Okay. Now, coming to that fact again. Here this is divisible by 11. 66 divided by 11 is how much? 6. What is that 6? The sum of these digits. Divide this sum by 11. 6 you got, no? That is nothing but the sum of these digits. Difference. 18, no? Divide by 9. What is that? 2. The difference between these two digits. Similarly, 84 and 48. 132. Divided by 11. What is the answer? 12. 12 is what? The sum of these digits. Similarly, difference is 36. Divide by 9. What is that? 4. The difference of these digits. Yes? 19 and 91. Sum is 110. Divide by 11. 10 is the answer. 1 plus 9, 10. 9 plus 1, 10. Similarly, the difference 72 divided by 9, 8. 8 is the difference between 1 and 9. Understood? Take any 2-digit number, reverse it and add them. You will get the multiples of 11. Take a 2-digit number, reverse it and take the difference. You will get the multiples of 9. Simple? Yeah? Similarly, we can apply it to 3-digit also. Just below that sentence, you write a 3-digit number. I'll show you practically. A 3-digit number and its reverse give the difference of multiples of give the difference of multiples of 99. 99. I'll show you. Give me any 3-digit number. 1. Reverse it. Here we can't find the same sum always. Sum doesn't have any kind of what? The relation. I'll tell you how. Okay. Take only the difference. 321 minus 123. Quickly. 321 minus 123 is 198. Can we divide it by 99? 99 twos are. What is that 2? That is the difference between the first digit and last digit. Here, the middle digit is ignored because when you reverse that one, same thing will come, no? These two are revolving. 2 is at the center only. So that doesn't matter. So the difference between the first and last digit is determining the difference here. Whatever the difference that is there between the first digit and last digit into 99 will be the final difference. Okay. Give another number. 4. 450. Reverse it. Take the difference. 396. Divide by 99. What is that 4? The difference between what? First and last digit. The central digit doesn't matter here. It will get cancelled with each other. And sum, we don't have a pattern for sum. Okay? There is no pattern for sum. For example, if we add this one, luckily, we get the pattern. The sum is 666. This is applicable only for these continuous numbers. For random numbers, it will not happen. 450 plus 54, it will give us the value of 504. There is no pattern here. There is no pattern here. So let us not worry about that. 2-digit, we have the pattern for both difference and sum. But for 3-digit, we have the pattern only for difference, not for sum. With this knowledge, we can solve many problems, and every year, at least one problem is coming in such type of questions. Okay, let us look into those questions. See here. Okay. Consider the difference between a 2-digit number and the number obtained by interchanging the positions is 54. Now tell me, what is the difference between the digits? What is this? The difference between 2-digit number, They have already taken one 2-digit number, and the number obtained by interchanging the position, that is the reverse of it, and their difference they are taking, and they are telling that difference is 54. I am asking, what is the difference between these digits? Read the second sentence. "54. 54 is a multiple of 9. What multiple of 9 is 54? Sixth multiple. That means the difference between these digits is 6. Yes? Understood? So if you enumerate those numbers which are having 6 as the difference between the digits, tell me those numbers where the difference between the digits is 6. Start always with 1. 17 is one number, and quickly reverse it. Take 2. Difference. Reverse it. Reverse it. One more number is there. See, if you go with 4 now, 4 plus 6, 10, you cannot write. One more number is there. Reverse it. 06. But 06 is not a 2-digit number. 06 is always a 1-digit number. Okay. So we have these many options. All these are giving the difference of 54 with their counterparts. With their counterparts, they are giving the difference of 54. Don't worry about the first sentence here. Come to the second statement. The difference between the two digits 17283960 of the number can be determined just by knowing 54. Can we determine the difference between the digits? Yes, that is possible. Yeah. So this statement is right. This statement is right. Read the first sentence now. The sum of the two digits. In all these cases, the difference is 54 only. Is it changing? It is not changing, right? Because the difference is remaining the same. Yes or no? Read this one. The sum of two digits of the number can be determined. You don't worry about this sentence further. Just read. The sum of the two digits of the number can be determined. Can we determine the sum of two digits? Yes? Yes? Okay. Now tell me. I have told you the difference between those numbers is 54. Tell me the number. Or tell me that number. I will only identify the sum of those digits. We have many options, no, here. Which number is final? Which number is final? Which number is final? Tell me. But if you take the difference, difference is same for all the numbers. Yes or no? But if you take the sum, is it same for all the numbers? Here 1 plus 7 is 8. Here 2 plus 8 is 10. 3 plus 9 is 12. 6 plus 0 is 6. But if you take the difference, it is common for all. 1 minus 7 or 7 minus 1. So, sum of the digits cannot be found out unless one more information is given. If they give one more information, then we can find out the sum also. So, one information, only with this information we cannot find out the sum. But this can be determined only if the product of the two digits is given. Let's say in this question, if they give this product of digits is 16. Product of digits is 16. Can we find out the numbers? Can we find out the sum of the numbers? Because among these numbers, which numbers are giving us the product 16? 28 or 82? Yes or no? So now, what is the sum of the digits here? If the sum product is 16, 10. 2 plus 8, 10. From this question, what you have to take to your mind is, difference of these numbers will always remain the same. Difference of these digits will always remain the same. That is, depending upon what they have given here. But the sum will change. To determine the sum, we need one more information, that's it. So they are giving the information in terms of product. I know for your stage, it is difficult to digest. But remember one fact, difference will remain the same, sum will not remain the same, that's it. Difference will remain the same, sum will not remain the same for such cases. And the difference is multiple of 9 and the sum is multiple of 11, that's it. Okay, fine. Yeah. So here, this is right anyways, this is also right if they provide one more information. If they haven't given this, then this sentence could have been wrong. Okay? Both 1 and 2. Yeah. Next. Consider all 3-digit numbers without repetition of the digits. 3-digit number without repetition of it. Without the repetition of it. Okay? Using 3 non-zero digits which are multiple of 3. Non-zero digits. So non-zero digits are what? 1, 2, 3, 4, 5, 6, 7, 8, 9 except 0. And that too, they are multiple of 3. How many multiples of 3 are there from 1 to 9? Which all are they? 3. Correct? 3, 6, 9. So we have only 3 digits and we have to form different numbers from this. When 3 digits are given, how many numbers can be formed? Let's say, for example, your mobile password is of 3 digits. And you know, you have kept the password among these numbers only, 3, 6, 9. How many times you will try? How many times you will try? You have used 3, 6 and 9. All 3 numbers. How many times you will try? So there is a pattern to try. First take the first number. Other 2 numbers you write. Keep the first number intact. Interchange the other digits. Take the second digit. Write other 2 digits. Again interchange them. Take the last digit. Write other 2 digits. Again interchange them. So you get 6 combinations. You get 6 combinations. Okay. Then for our mobile password, it is of 4 digits. You know the numbers, but you don't know the order. So it varies. It is part of permutations and combinations. We'll discuss then. Now these all are the possibilities of 3-digit number where the digits are divisible by 3 and they are non-zero, non-repetitive. Yes? They are telling, consider all these digits. Let S be their sum. We are finding their sum. We are finding their sum. Anyways, these digits have been interchanged with each other. In each row, you will find 2 3s, 2 6 and 2 9. Here also 2 3, 2 6, 2 9. Here also 2 3, 2629. So whatever that you get here, here, it's all same. But since we give carry, it's, the position of the numbers change. Okay. Here, add them. 9 plus 9 plus 6 plus 6 plus 3 plus 3. Total sum will be 36. Total sum will be 36. But we don't write like this. Here also we get 36. Here also we get 36. Sum. But while writing, how do we write? 36, we keep 6 here. Give 3 as the carry. 36 plus 3, 39. Then 36 plus 3, 3996. So this is the sum. 3996 is the sum. They are asking, S is always divisible by 74. I have not taken it, just I am considering it. S is divisible by 74, yes or no? I had asked you to remember the fancy numbers like 111, 222, 333, 444. Isn't this number like that? Though after some we get this like this, but it is actually the multiple of 111 only. I have told you whenever 111, 222, 333 comes, they are divisible by 3. They are divisible by 37 also. Yes. It is an even number or odd number. It can be divisible by 2. Yes. I have told this number is divisible by 37 because it is divisible by 111. And this number is divisible by 2 also. So this whole number is divisible by 37 into 2. 37 also can divide. 2 can also divide. So 37 into 2 is what? 74 is double of 37. 111 is triple of 37. Keep these numbers. These are going to help you in one or the other way. Double of 37 is 74. Triple of 37 is 111. Okay. Done? No issues? Yeah. S is always divisible by 9. Apply your brains. All the numbers that we have chosen, they are multiples of, correct? They are multiples of 3. And what options we have? 3, 6 and 9. Make the sum of 3, 6 and 9. How much it is? Make the 18. Again 1 plus 8, 9. So, take this number, isn't it divisible by 9? And we have jumbled the numbers and written. So, every number we have written here, all these 6 numbers are divisible by 9. Just the order of the numbers, order of the digits is different. Yes? So, 9. So, when all the numbers are divisible by 9 and when we add them, it is also divisible by 9. Try practically, no? 3 plus 9, 12, 12 plus 9, 21, plus 6, 27, 2 plus 7, 9. So in such cases, where we are jumbling the digits and adding them again with all possibilities, usually they are divisible by 3. Usually they are divisible by 37. This is for sure because they are divisible by 111. All other things, it is applicable. Since it is an even number, that is also divisible by 74. Since they are multiples of 3 and all the numbers are multiples of 9 and even the sum is multiple of 9, this is also multiple of. But the basic is what? They are divisible by 37. They are divisible by 3. That is what you have to remember. Whenever 111, 222, 333 comes, your mind should go to 37. Done? Yeah. Without practice, without remembering, without pressurizing your memory, it is going to be difficult. So many small topics I am dealing. You have to revise. Other chapters, whatever that we deal, from average, percentage, profit and loss, similar types of problem will come. There are no varieties of problems. But in number system, there are too many varieties of problems. So small things you have to be aware of. Okay. Next, similar problem. Let XYZ be a 3-digit number. XYZ. And X plus Y plus Z is not a multiple of 3. See, even the examiner will play with 3 and 9 only in such problem. Because the examiner knows this particular number 111, 222, 333, they have something to play with 3. That is why they will give the game with 3. Then XYZ plus YZX plus ZXY. See, this is XYZ, YZX plus ZXY plus add them. What is this? X plus Y plus Z. This is 1 digit. What about this? What about this? Same thing. Isn't this number a fancy number again? I don't know what number is this, but it is repeating for 3 times. Yes or no? Same number, no? X plus Y plus Z, X plus Y plus Z, X plus Y plus Z. This is repeating for 3 times. Tell me, this number is not divisible by, they are asking. Whenever not comes in the paper, maybe it is GS paper or CSAT paper, first make sure that you are reading the sentence without not. Make this practice. It will save you 2 questions for sure. Because when not comes, it is very confusing. Okay. First make sure that there is no not and you are reading without not. Now read, then this sum is divisible by 37 for sure, 3 for sure, X plus Y plus Z for sure, because this number, no, maybe it is 2, maybe it is 5, maybe it is 8. This is repeating for 3 times. For example, 555. Isn't it divisible by 5? Yes? So it is divisible by 5 also. Now remove this. Which is not divisible. This has to be the answer B. Make this practice even in what? Even in GS also. Okay, this is going to save your 2 or 4 marks for sure. Because many people make this mistake while reading not. Sometimes they don't look at not at all. Wherever not comes, you put a box on that. Always make sure that you are looking into the not questions. In one of my attempt, in full Josh, I was going through the questions. I solved nearly 40 questions. Suddenly I came across a question which was having not. Then I remembered, I have not seen some nots. Then I went and see, in the older questions, 2 nots were there. That means what? Because I had already bubbled. We are telling from our own mistakes. And these are practical ones. Okay? So always read the sentence as if not is there, not there. Then tick. Then remove that one. Then take the option which is not ticked. Okay? Fine? Yeah. Squares and square roots. These are again like very, what I can say, very important and like application oriented, what? The numbers. For example, squares. Tell me the squares. 1. Tell no. 9, 16, 25, 36, 49, 64, 81. I'll take 0 also in the static. I'll show you some pattern. Consider this one, 25. Look at the numbers around. You focus only on the last digit. Same. Same. Take any number ending with 5 and you will see the pattern like this in the squares. I'll take one more. Square of 25, 625. And I'll write the squares of the numbers before that. Don't get amused, I don't remember them. I am using certain pattern and writing. 20 square is 400. This is 25 square. Look at the last 2 digits of the squares. 76, 76. I know these, that is why I could write this. So that beautiful is maths. If you go on finding patterns, no, you will get completely immersed into that world. Okay? So many patterns we can find. Again, tell me the difference between these two. These two. These two. These two. These two. What are these? Consecutive odd numbers. There is an application. Yeah. So this is the basis of telling that sum of first n odd numbers, sum of first n odd numbers is equal to n square. Sum of first two odd numbers is how much? 4, no? Sum of first 3 odd numbers? 9. Sum of first 4 odd numbers? Sum of first 5 odd numbers? Okay, I don't have to amuse you on every second. Okay, and this is not the time for amusement also. Yeah, this is time to score those 66 and get rid. Okay, and we have a lot of applications in squares and square roots also. Okay, squares and square roots. So kindly remember squares from 1 to 25. This is compulsory. Apart from that, I would like to tell you few more facts that you have to remember. Anyways, 1 to 25, remember? 1 to 10, 11 to 20, and up to 25, you know. And squares of 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. You know, right? At least you can get to know within 5 seconds. Yeah, that confidence I have. Yeah. Coming to the number which are ending with 5. Let us discuss upon that. 5 square is nothing but 5 into 5. What is the answer? 15 square. 15 into 15. What is the answer? 25 square. 25 into 25, 625. 35 square. Have I done this? No, right? No. There is a pattern. Whenever we are multiplying two numbers ending with 5, the last two digits are fixed. 25, 25, 25. If we are finding the squares, instead of 1 ones are, make 1 twos are. Instead of 1 ones are, make 1 twos are. What you will get? Instead of 2 twos are, make 2 threes are. Instead of 3 threes are, 3 fours are. What is it? It is not time to relax. Write all the squares of numbers ending with 5. Quick, complete. You don't have to write the expansion of it. Write directly. Why waste time in writing that expansion? $2,025, $3,025, 4,225, 5625, 7225, then 9025. Done? Yeah. So this will help you one or the other way. Okay, fine. And recently again the questions started coming up from squares now. Squares. One such problem I have found out. How many pairs of natural numbers are there such that the difference of whose squares is 63? How many such natural number are there? Difference of whose square is equal to 63. You have to consider two natural numbers. I'll consider x and y. Okay, x and y. Difference of the squares. This is what it is, right? Difference of the squares. Two numbers, two natural numbers are x and y. Difference of whose squares? Difference of whose squares? Correct? Yeah. Yes or no? Now, you know in the school, this has been mucked up for 1000 times. X square minus y square or a square minus b square. What is that? Basically, 63 is a number. We have to find its factors and they have to be multiplied to get this 63. And I have told you the practice of finding the factors. 63 can be written as 1 into 63, 3 into 21. Then next is what? You don't have to be silent, okay? 7 and any other thing that we can do? Any other thing? That's all. How many pairs of these numbers? 1 and 63, 3 and 21, 7 and 9. Correct? So here, this is one number, this is another number. We are multiplying them. How many options we have? This is one pair, this is second pair, this is third pair. So we have, but to understand them practically, you can take them and substitute here. That means x plus y is equal to 63, x minus y is equal to 1. You will get x as 32 and y as 31. So basically, the difference between 32 square and 31 square, it is nothing but 63. Similarly, the difference between 63 square, 63 square, what I am doing here, okay, 21 and 3, 21 and 3. So basically, when you substitute 3 for x minus y and 21 for x plus y, you will get the values of x and y as 12 and 9. That means 12 square minus 9 square is equal to 63. Similarly, 7 and 9 you put x plus y is 9 and x minus y is 7. So you will get the values of x and y as 8 and 1. So 8 square minus 1 square is equal to 63. See, here we got 3 pairs. Those pairs have to be substituted here. I will take one pair and tell you 1 and 63. X plus y is equal to 63 and x minus y is equal to 1. You know how to solve this. You know how to solve this, right? I am not here to teach that. This will get cancelled. 2x is equal to 64. So x is equal to 32. When x is equal to 32, y is equal to 31. Similarly, when you put this 21 and 3 here, you will get the values of x as 12 and value of y as 9. Similarly, when you put 9 and 7 there, x value is 8 and y value is 1. Fine? It takes time to digest. But this is the way. You have to solve such problems. Okay? Fine? So here 3 pairs totally. Totally 3 pairs we are getting. Okay? Progressions. In the forthcoming class, I'll be taking number series. So I'll take this progression then. Okay? These progressions then. Actually, in our arithmetic or in this quantitative aptitude, we don't deal with algebra. We don't deal with algebra. But we use equations. We use equations. Equations in 2 variables. Equation in 3 variables we use. For example, how we use this x plus y into x minus y. Or x plus y plus z. Like that we are using variables. And finally we get to the value of x, y or x, y and z But you have to remember one particular fact here. While you are writing those sentences into the equation format, you use the variables X, Y, Z or A, B, C or M, N, O, P, whatever. You should try to use as less variables as possible. Otherwise, you will complicate the issue. You have to write as less variables as possible, because while we solve for these equations, we have to construct those many equations as the variables. For example, if you are using X and Y as the variables, two variables, you have to construct two equations to get the solution. If you construct only equation out of X and Y, you will not get the solution. If you are using three variables in the problem, you have to construct three equations to get the what? Solution. Otherwise, you will not get the solution. So write this down. Write this down with a box or highlighter or star. The number of variables should be equal to the number of equations to get the complete solution. Otherwise, the solution will be partial. You don't write this, okay? Otherwise and all. Yeah. For example, you have three variables, but if you construct only two equations, you will not get the solution for all the variables. Okay. So while writing the equation, be mindful. So we'll discuss one or two equations here and leave. This is a bit tougher, I'll take later. This is very important. Because you are writing one such objective type of test, that is preliminary examination. Even today, after solving many objective type of papers, right from 10th, 12th, CET, all that thing, people don't know how to calculate their scores. Even the people who have written 3, 4, 5, 6 attempts, they fail to finally calculate their scores. In our examination, how many marks are given? GS paper. How many marks are given for a right answer? 2 marks. How many marks are given for the wrong answer? So basically, 1/3 of the marks are cut, or the penalty is 1/3 of the maximum marks allotted to that one. Yes or no? So if the maximum mark is 2, 1/3 of that, 2/3 will be cut. So for every right question, you will get 2 marks. For every wrong question, you will be cut with minus 2/3 marks. Then you will calculate the total. And also there are few questions which you have unattempted. For that, there is no penalty, but the marks will not be allotted to that, or the marks allotted is 0. Then you find out the total. Yes or no? If you know how to calculate your score at the end of the day, it is good. Usually we get what? Total number of questions will be 100. And don't fix up anything in your mind that all the time you have to attempt 80, 85, 90. Few people in the market will tell you have to attempt 95 only. There is no such rule. But whatever the number of questions that you attend in GS, make sure that you are getting 65 right on any day. On any day, you have to get 65 right. no matter how many mistakes are making. If you make 65 correct, then the maximum number of wrongs that you can make is 35. Beyond that, you can't make, no? Only 100 questions will be there. Even then, if you calculate your score will lie somewhere as 106.6. That is good enough to clear the paper. Try to reduce the number of wrongs. But on any day, if you score 65 right answer, you will get through. So, target is 65. Chicken 65, gobi 65. And finally, the marks are the right questions 65. Okay. So, I'll show you this calculation, but I am telling you our calculation for our examination. Get 65 right on any day. You will get through. Okay. In this question, the right questions, in the question, like for the right question, 5 marks are allotted. For the right question, 5 marks are allotted. For the wrong question, 2 marks are deducted. And for unattempted question, they have not given anything. And this fellow, after attempting all the 90 questions, this fellow has not left any question. He has put 1, 2, 3, 4, 1, 2, 3, 4. Goli. Okay. He has shot every question. And finally, his score is how much? 387. Here. Tell me, when he has not left any question, his number of right questions plus number of wrong questions. How much? 90. Very good. 5 marks are given to every right question. And 2 marks are cut from every wrong question. Cut minus. And finally, how much he has scored? 387. 387. Correct? Yes or no? Now, how many variables are there in the equation? How many equations are there? 2. Can we solve? I'll show how to solve. And in these equations, what is our goal? What we have to find out? R and W. That is our practice since childhood. For a given equation, we would like to find out both the values. But what is asked in the question? We have to get only W. Don't worry about R. Don't waste your time in finding R. In the first go only, you find out W. In both the equation, R and W are there. You want the value of W. Kick out R. Kick out R means cancel R somehow. From these equations, cancel R. How can you cancel R? You have to make 5R here. So we will multiply this whole equation by 5. So what it will be? 5R plus 5W is equal to 450. Correct? Now, minus, minus, minus. R is gone. Minus 2W minus 5W. Minus 7W. 387 minus 450. Minus 63. W is equal to? W is equal to 9. So that person has made 9 questions wrong. How many questions correct? That is not required for my curiosity. 81 correct. And 9 wrong. This is dream. This is dream. In none of my attempts, I have crossed 61. No. Once I have crossed. Otherwise, always my right answer would be around that number only, 50 to 60. Whenever I have failed, I have made, the number of rights somewhere around 50 to 55. Whenever I have cleared, my rights are always around 60. But once very bumper crop, 67 correct and 21 wrong. That time I had scored 120. That is the only time I had scored 120. Otherwise, all my GS scores in 90s, late 90s only. 96, 98, 99. Sometimes clear, sometimes don't clear. So that is how it used to be. So always make 65 correct. No matter how much wrong you are making. And if you target the number of wrongs, it should not cross 15 on any day. On any day, your number of wrongs should not cross 15. First, make that practice. Your number of wrongs should not cross 15. If you maintain this ratio, 65 right and 15 wrong, that is dream. Your score will be 120. Yeah? First, practice to make less negatives. Then increase your positives. Okay? So don't take risk unnecessarily. Okay? Fine? Done? So rest of the problems we'll solve tomorrow.